All right, in this lesson we are solving and graphing compound inequalities. Just like compound fractions have fractions inside of another fraction, compound inequality is a mathematical sentence that contains more than one inequality. The inequalities are connected with either an and or an or. With and compound inequalities, the solution is the intersection of our two graphs. And compound inequalities are written with the less than or equal to symbols before and after the variable. The number in front should always be smaller than the number in the back. The graphs of and compound inequalities typically look like this. So if we graph the first part of that inequality, which is x is greater than or equal to 2, that graph looks like that. And then when we graph the other inequality, the x is less than or equal to 5, the graph looks like that. And again, the and compound inequality refers to the intersection of the two graphs. So this is the area or the space where those two graphs intersect. So that is our solution. And to describe that interval, we say that x is between 2 and 5, including the 2 and the 5. With or compound inequalities, we are going to combine the two graphs. Or compound inequalities are written with the less than sentence and a greater than sentence separated by the word or. We typically write the less than sentence first, the or, and then the greater than sentence. The graphs of or compound inequalities typically look like the following. So we're going to graph this compound inequality. We start with the first inequality, x is less than -3, open circle at -3, arrow pointing to the left. And then the second inequality, x is greater than 5, should also be an open circle at 5, arrow pointing to the right. And since or compound inequalities, we're combining both graphs. That is actually what our graph looks like. The arrows are pointing away from each other. All right, so if we solve this compound inequality, first thing we want to do is multiply the first inequality by 3, both sides. And the second equality, we're going to multiply both sides by 10 to get rid of the fractions. That leaves us with n is less than or equal to 0 for the left inequality. And for the right inequality, we have n is greater than or equal to -10. All right, so we just want to write that as one combined expression. So we have n is greater than or equal to -10, so the -10 should be on the left side, and n is also less than or equal to 0. Again, the smaller number should always be on the left. The bigger number should always be on the right, and you should have a less than symbol on the left and the right side of your variable. If we graph those, first one, n is greater than or equal to -10, and then n is less than or equal to 0. Again, the graph or the solution is where those two graphs intersect, since this is an and compound inequality. So the left circle is closed, the right circle is also closed, and the arrows are between the 2 points. All right, to solve this inequality, we basically have two sentences, so we're going to add 3 to both sides of both inequalities. When we add 3 to the left inequality, we get -4 is less than or equal to m. When we add 3 to the right inequality, we get m is less than 3. And again, to graph that, we start with the m is greater than or equal to -4. And then the m is less than 3. And again, the solution is where those graphs intersect. At the left circle, we've got a closed circle. At the right circle, we have an open circle. And the arrows are between the two numbers. All right, solving the next compound inequality, which is an OR compound inequality. To solve the left inequality, we add 2 to both sides. To solve the right inequality, we add 10 to both sides. Next step, we're going to divide -7 from both sides of the left inequality, and then we're going to divide both sides by 10 on the right inequality. When we divide both sides by the -7, it's going to change the direction of the inequality. So we get v is less than or equal to 7, or v is greater than 9. Again, the solution is the combination, or combining both of these graphs. So that is our solution. That is the graph of our solution. The left circle is closed, the right circle is open, and the arrows are going away from each other. And the last example, we want to start by subtracting 8 from both sides of the left inequality, adding 4 to both sides of the right inequality, and we get our solution. N is greater than 3, or n is less than -2. We typically write the less than sentence on the left, or then the greater than sentence on the right. If you graph those, n is less than -2 looks like this. N is greater than 3 looks like this. The left circle is open. The right circle is also open. And the arrows are pointing away from each other.